Okay, so in this video, we are going to be talking about intermolecular forces. And so just basically what intermolecular forces are and what they help us understand. So they usually start off terms to know. The term to know today, dipole, basically just another way of saying a polar molecule. Here, I've got this lovely illustration here showing you how you will often see dipoles written with the little, that's a lowercase delta, by the way, delta plus and delta minus. That means there's a partial positive and negative, right? These are not ionic, but they are polar molecules. The other way that you can see this sometimes is with an arrow, right? This, and it has a little cross at the bottom there, and it points in the direction of the negative, unless you are British, and then I believe it points in the direction of the positive. But as we are here in America, we point in the direction of the negative. And so that is the two ways where you will see dipole indicated, right? So the partial positive and partial negative. So there are 5 types of intermolecular forces, or IMF, that we'll be discussing in this video. Here are the 5. I'll go through each of them on their own in this order. So the first one, ion-dipole interaction. And basically, it's just an interaction between ions and the oppositely charged part of a polar molecule. It is the strongest of the intermolecular forces, and a common example of this is some sort of salt dissolved in water, as you can see in the picture here, where we have the positive ends of the polar molecule, in this picture water, that are facing towards the negatively charged anion, in this case chloride. And then in the other picture, right, the negative ends of the polar molecule, or the oxygen on water, right, facing towards the positively charged cation, which in this case is sodium, right? So sodium chloride dissolved in water. Essentially, it's the interaction between the oppositely charged end of a polar molecule and some sort of ion. So that's ion-dipole interactions. The next is dipole-dipole interactions. And if you remember from earlier in the video, right, dipole is another way to say polar molecule. So really all this is an interaction between the oppositely charged sides of 2 polar molecules. And hopefully this diagram looks familiar as you saw it maybe about a minute and a half ago. And here we have hydrogen chloride, or hydrochloric acid, right? And there is an interaction between the partially negative side, right, the chlorine, and the partially positive side, the hydrogen. And so those two are interacting, and they are attracted to each other. Now, this is a special case of dipole. Dipole, the hydrogen bond, right? So it is called a bond. In the past, it has been said that this is not a bond, despite being called a bond. There is some mounting evidence that there actually is a bond, but we will leave that discussion for another time, or I will leave that discussion for when you take chemistry in college, when you're all going for your chemistry degrees. So, as I said, a special case of dipole. Dipole, which occurs between the hydrogen on one molecule and the partially negative atom on another molecule. And there are some rules. It can only take place between molecules where hydrogen is directly bound to nitrogen, oxygen, or fluorine, right? So if hydrogen is not bound to one of those three, it is not a hydrogen bond. Right, so like we saw in the last example, dipole, we had hydrogen and chlorine. That is not a hydrogen bond because hydrogen is not bound to nitrogen, oxygen, or fluorine. So these bonds or interactions are stronger than dipole-dipole, but they're weaker than ion-dipole. And these are extremely important for life, right? Because hydrogen bonding is in water. It's what helps water to have a lot of the important properties that make it so great for living things. This is also the type of interaction that essentially is holding our DNA together, which, if you remember biology, DNA, a pretty big deal as far as life is concerned. It also has a lot to do with how proteins fold and take their shape, which, again, if you remember from biology, proteins, pretty big deal for life. So hydrogen bonding is a type of bonding that's really important, especially for living systems. Next one, dipole-induced dipole interactions, and this is where intermolecular forces, I feel like, get a little bit tougher to visualize, and so I've got some descriptions here, right? And so my description for dipole-induced dipole, it's like when you ask your friend to go see that scary movie with you, even though you know they don't like scary movies, and they go because, you know, they're your friend, right? And that's kind of like dipole-induced dipole interactions. It's an interaction between a polar molecule and a nonpolar molecule. It's basically caused by the polar molecule pushing or pulling on the electron cloud of a nonpolar molecule and causing it to become temporarily polar, right? So, you know, the polar molecule is like, hey, come on, there's this great movie. And the nonpolar is like, I don't know, I heard that movie was kind of scary. And you're like, oh, but I really want to see it. And, you know, the nonpolar molecule is like, okay, like I'll go. I'll just cover my eyes during the scary part. And, you know, it's what happens. And they have this, like, little interaction, as you can see from the picture, right? The partial negative, partial positive causes a partial positive and negative in the nonpolar. Right, so that is the situation with dipole-induced dipole interactions. The last one, there is a group of forces or interactions that van der Waals and the London dispersion forces both fall under. They are slightly different, but for this class, we group them both together. And so for this one, I said it's like when you're hanging out with your friend, you say, man, I'm bored. And they say, oh, me too. You say, want to go do something? They're like, yeah. But then neither of you really knows what to do, and so you just kind of go back to sitting there and binge watching The Office. So in this one, right, interactions between two nonpolar molecules. So it's two nonpolar molecules that are interacting. And this one, it occurs due to random shifts in the electron cloud of a nonpolar molecule, causing it to become very briefly polar. This causes a shift in nearby molecules, making them briefly polar as well. And then they go back to being nonpolar. So this is the weakest of the intermolecular forces. And this one, while I say the weakest, the strength of the interaction, right, is going to be dependent on the size of the molecule. Larger molecules, there's more chance for these shifts to happen, and so the strength is going to increase as the size of the molecule increases, right, before they both go back to being nonpolar and just sitting there on the couch binge watching Netflix. So that's it those are the 5 types of intermolecular forces. Things to remember. So intermolecular forces occur between 2 or more molecules, right? Bonds, which you could also call intramolecular forces, occur within a molecule. The type of intermolecular force in a substance is primarily dependent on the polarity of the molecules involved. So if you remember from the last video, talking about molecular shape, right, and how that plays into polarity, right? So IMF has a lot to do with shape and polarity. Hydrogen bonding only occurs when hydrogen is bonded directly to oxygen, nitrogen, or fluorine. And all types of intermolecular forces are weaker than bonds. That is it for the intermolecular forces video. I will see you in class. Remember, there is work related to this up on campus.